Hi, good day. Welcome to our chemistry class. Today, our task is we will try to deal the FRQ questions, or what we call as the free response questions. In the screen that you can find there, the questions are: the element fluorine has an atomic number of 9. A, write the complete electron configurations. B, write the noble gas configuration. C, show the valence electron dot structure. And D, draw the orbital diagram. So in these free response questions from letter A to D has a corresponding marks. If you write the complete electron configurations correctly with fluorine, you will get 2 marks. And if you write the noble gas configurations, another 2 marks. And if you show the valence electron dot structure of fluorine, another 2 marks. And if you draw correctly the orbital diagram of fluorine, is also 2 marks. And for this question alone, you will be earning 8 marks. So let's try to start. For letter A, in writing the electron configurations, we have here the periodic table of elements. So you notice that this is our fluorine located. So located in group number 7, or has it is in group number 7 and period number 2. Okay, so this is 2, this is 1, 3, 4, 5, 6, and 7. Now, it's really very easy. So we'll just start with here. So take note, these are our s orbitals. So that will be, when we talk about letter A, what? S2. And then we go to the 2 s orbitals, 1, 2. So that becomes 2s2. And the last one here is we are in the p orbital. So we have 1, 2, 3, 4, and 5. We reach F. So that is 2p5. Guys, take note that fluorine has an atomic number of 9. If you're going to total all these electrons, you will also get an atomic number of 9. So with that, you'll be earning a full marks of 2. Now let's go to letter B. Letter B question says, write the noble gas configuration of fluorine. Now, as we learned from our previous lesson, we know that a noble gas configuration are all elements that is found on this part, or in this group number 8. So we will be using that. This is the noble gas configurations of our helium. So instead of writing 1s2, we will just write square bracket helium, and then just simply copy the second orbital diagram, which is 2s2 and 2p5. And that is our answer for number or letter B, which is the noble gas configurations of fluorine. Now, how to deal with letter C? So for letter C, it's very easy. So you just simply follow the groups. The groups that you are actually talking is the number of valence electron. So the valence electron tells you, or can be shown using the Lewis dot structure. So this is group number 1. So all groups from this one here, this is actually group number 1 that has a valence electron of 1. Group number 2, all these elements there contains 2 valence electron. Group number 3, this one here, all this element that is actually here has 3 valence electrons. Group number 4 has, and so on and so forth. So group number 5, this one, nitrogen, and so on. So fluorine is actually belongs to number 7. Okay, so therefore it is 17 or 7. So fluorine is there. Now we will just simply write F, which is symbolized our fluorine. Now we will write our electron dot structure, or electron dot Lewis dot structure. So we'll make a square, 1 up, 1 down, left and right. So take note, we need 7. Okay, so we need 7. So 4, so we will go back here, 5, and then 6, and then 7. And that is the electron dot structure of our fluorine. All right, so let's try to move on. Letter D. So for letter D, you can use the orbital diagram vertically or horizontally. So I'm very comfortable using the orbital diagram in horizontal way. So I will just draw a box. This is for my first energy level, second energy level, my 2s, and then my second orbital, which is second sub-level, which is my 2p orbitals. So take note, my 2p orbitals has 3 sub-levels. And then I'll go to the third orbital, which is 3s, and then and so on and so forth. So in this case, it's really very easy for fluorine. So fluorine has an atomic number of 9, okay? So this is the atomic number of fluorine. So we will just distribute that one in our orbital diagram. So it is how it look like. So we will follow the Aufbau principle, the Pauli exclusion principle, and the Hans rule. So first, we will occupy first the lowest energy level, 1 up, 1 down. So we already spend 2 electrons. So 9 minus 2, we have already 7. And then we will go to the next energy level, which is 2s, 1, 2. So minus 2, we only have 5 more electrons to be distributed. So we will start here, 1 up, 1 up, and 1 up. And with that rule, we are following the Hans rule, that we need to distribute the energy or the electrons first in the same sublevel because they possess the same energy. So we have 3, and then we move down. That's the time that we can spin a complete spin for that. So we have 5 already. And that is the complete orbital diagram of our fluorine, which has an atomic number of 9. Hope you get it. All right, so before we end, I would like you to try this example. Instead of fluorine, try to do phosphorus. Okay, I want you to do phosphorus. Phosphorus has an atomic number of 15. Same, you're going to write the complete electron configuration, write the noble gas configuration, show the valence electron dot structure, and draw the orbital diagram. Thank you and good luck.